Hello everyone, so welcome to the lecture 9. So here we are going to discuss about segregating odd and even nodes. So first let's see how the structure exists. So let's say this is a single linked list. So this is mainly a LeetCode problem. So yeah, I said I'll paste the link in my blog of all where you can practice. So let's say this is the head of a linked list and this is the tail of a linked list. Okay, so we don't care that much about tail here, we only care about head. Okay, so let's say what does it mean by separating odd and even nodes. So let's consider this position. So in LeetCode it was mentioned that the first node consider it as odd. Okay, so it's basically you can see anywhere, you can even start with even, but let's take the problem as an example so it will be easy to refer. So now the first node will be odd. Let's say this is 1, this is 2, this is 3, and this is 4, this is 5, and this is 6. Okay, so what does it mean by segregating odd and even nodes? Let's say what are odd nodes? 1, 3, 5, right? What are even? 2, 4, 6. So that means first you need to group all the odd ones, which means 1, 3 and 5, and next you need to group all the even, that means 2, 4 and 6. So in this way you need to structure your program so that this groups into the first odds and the next will be the events. Okay, so let's see how we can solve this problem. So first let's keep a current pointer at this position. So let's say a current pointer, and we'll maintain 2 pointers for every odd and every even. So let's say we maintain 2 pointers for odd. One is odd head and other one is odd pointer. Okay, so now the next one is even head and other thing is even pointer. Okay, this points to the head, this points to the head of the odd, this points to the head of the even, and this pointer moves. Okay, so now let's see how we can configure this. And we also will keep a variable, something called what is a correct index. So the current index is 5 because the current index is 1. Why? Because we're starting from index 1. Yeah, it may seem the index is 0, but in the question it was mentioned that you consider first node as 1, means index. Okay, so I'm simply considering C as 1. Okay, so now if let's say C is odd, okay, that means the first node. So initially odd node is nil, this is also nil, this is also nil, and this is also nil. Okay, so now when C is odd, that means first we'll check whether the odd head is nil or not. If the odd head is nil, that means there is no list which is found by odd, right? I mean the odd linked list, there is no odd linked list. So now what we'll do is we'll make odd head as our current pointer, which is this is the first node, right? The first node, and next odd pointer will also mark to odd head, right? Because this should start traversing from here. Okay, now let's say in the same way, what if an else case will become? It will become the same with even, right? Yeah, with even. Okay, so now let's say now we have traversed the first node, we have made this to point to the first node, this is also the first node, and after the second one we'll mark this to second and we'll mark this to second, right? So now when we reach third, that means the odd head is not null, which means we have some value, right? Odd head is not equals to nil. Okay, so what we'll do in this scenario, we can simply make sure that, see, the odd pointer is already pointing to its list. So in the odd, let's say this is 1, and here an odd head is pointing, an odd pointer is also pointing this particular thing. Okay, so now here whenever the odd head is not nil, then what we need to do is we need to point this particular node to the third node, right, which is our next odd node. That means we can simply make odd pointer dot next will be equals to third node, right, which is this one, which is current pointer. Okay, and now we can simply move the odd pointer to forward. So we can simply make odd pointer is equals to odd pointer dot next. In the same way we can do for even also. Okay, so let's say we have traversed the entire thing, so entire single linked list, and now this will be 5, and so odd pointer will be pointing to here, right, here. This is odd pointer, and now when we see the even linked list, here 2, 4 and 6, right, so the even head will be pointing here and the even pointer will be pointing here. Okay, so now first odd and then the attached with the even, right. So to form this sequence, what we can do, we can see that the odd pointer is the ending of the node, which is tail of the odd linked list. So that means we can simply say odd pointer dot next will be just equals to even head. So that means we are simply joining these two, right, we are simply joining these two. Let's say there may be some case, can you say whether odd is not there? Is there a chance whether odd is not there? No, right, we cannot say the odd is right, odd is not there, because without even existing 1, how you can count it as 2, right? So you'll at max you'll have either linked list length equals to 0. Let's say linked list length is equals to 0 and odd equals to 0, right? This is must, so this should validate. So hence we can simply return our odd node, we can simply return our odd head, which is formed by this thing. So it will be like this, right? We can simply say, let's say what if even there is no even node, that means only 1 and 2. Sorry, there is only one node, right? Even nodes, there are no even nodes. That means we can simply return odd head, right? You need not make any other if conditions to pass this condition. Okay, so I hope you understood the problem of segregating odd and even nodes. So let's jump into the coding session. So let's see how we can structure this particular code. So as mentioned, we'll keep a current pointer which will be pointing towards the head, and now let's create 4 pointers, which is even head, odd head, even current pointer and odd current pointer, right? And now we will make that c is equals to 1, because first node we considered it as odd, right? So now for the current, until we loop until it's null. If it's an even node, then that means if even node is null, then we'll point this even node to the current pointer and even current pointer to the head, right? If it's not the case, then even current pointer dot next will point to the current pointer and we will increment the even pointer, and same is applicable to the odd. Okay, so now we'll simply make sure that when you attach a node to the odd or even, you need to break the link, right? So simply we are keeping current pointer dot next equals to null, and we need to move forward, so we are like prematurely storing the next pointer, and now we are simply incrementing the count here. Okay, let's say we have looped the entire thing, and now let's say odd head is not equals to null, right? I think because odd head can be null, right? If there are no elements in the entire thing, then odd head can be null. So to avoid that scenario, simply let's say if odd head is not null, then we can simply point odd current dot next to the even head. In this way we can solve this problem of aggregate odd and even nodes in a single linked list. I hope you got the problem. So make sure to like and subscribe, and feel free to comment in the comment section. If you have any doubts, make sure to comment on the blog also. I'll be replying there. Yeah, I hope you like my videos. So let's meet in the next session.